All right, guys, here we go. We're going to start talking a little bit more definitively about our ellipses. All right, so here we have an ellipse, and we saw previously that the ellipse is and can be named with a pair of parametrics as defined below. X equals a cosine of theta, and y equals b sine of theta. Of course, the parameter more often than not is going to be used as t, but for our purposes moving forward, we're going to eliminate the parameter, which we saw we could do by taking advantage of the sine squared plus cosine squared equaling 1. And you should go back and refresh your memory as to how we get this parameter eliminated and derive this as our as our rectangular equation for the parabola. Okay, so we're going to talk about that in terms of what these a and b values are, and somewhat about the orientation of the parabola. Okay, so the parabola is can be elongated along the x-axis or the y-axis. Okay, and the length DE, which is the major axis, only because it's longer. Okay, and we're going to see how we find that value in just a second. Okay, and that will be shown to be twice the value of A, and the minor axis, which is the shorter, will be twice the value of B. And in some orientations, we're going to see this is going to be the longer along the y. And we'll see that. The equation is going to look very similar. It's just a matter of calling A the larger value. So the minor axis is of length 2b, and the major axis is of length 2a. And we're going to show you that in just a minute with a Desmos link here. Okay. So we're going to say, as pointed out here, okay, a couple things going. All right, taking a look at an ellipse centered at the origin, okay, of this variety, x squared over a squared plus y squared over b squared equals 1. The orientation with a being larger is with the major axes along the x, and it being of length 2a. All right. On the major axes are the foci points, which are labeled here as C and C prime. They're the foci points. Okay. The vertices are the endpoints of the major axes, so they're going to be at negative a and positive a. Okay, and so we can always find our go back up into our equation, setting x equals 0. We'll find the points at b along the minor axes, as well as the points a along the major axes. Okay. In the event that we're orienting this with the major axes running vertically, okay, same convention. The foci points are going to be on the foci point are going to be on the major axes, but the larger value A is going to be underneath the y variable, so it's going to imply that the orientation is vertical. Okay, so the vertices again are typically stated to be the endpoints of the major axes, and again the foci will appear on the major axes. Okay, so the foci in this orientation are at 0 C and 0 negative C. Okay, we're going to hold off on that for a minute. Okay, we're back. We're looking at Desmos, and I'm going to provide this Desmos link for you right here as well. Okay, so here with this Desmos link, we have the defined ellipse right here. Okay, we've got A. We're going to try to keep A larger than B at all times for this, because that's the way this one is set up. We'll look at another one. But here you can see that the A is 5, so the span is the major axes in the along the X spanning from -5 to +5, so the span there is 10, okay? And the minor axis is spanning from -4 to +4, okay, along the Y. Our foci points are here, okay? And they'll be shown to be at 3 and -3. We'll show you how they're computed. There's a formulation right there. We'll derive that in a future video. But the thing that we're trying to impress upon you is the major axis is going to be 2A. So here it is. The major axis runs from 6 to -6. So that's a span of 12 units. So the major axis is 2A. The minor axis, of course, is going to be here now at 4, running from 2 to -2, okay? And again, you can see what's happening to our foci point. Our foci point, as it tends to get flatter, is moving more and more towards the vertices there at the -A and +A, okay? So we'll provide you the link to that so you can explore that some more. Of course, with A and B being equal, we're going to be looking at a circle, and of course, in looking at the circle, the foci points are meaningless because there's not 2 foci points. There's but one focus, or should we say, the radius. And the more we're going to talk about an eccentricity factor, which is not represented here, but the eccentricity factor we're going to talk about is how this thing is deviated from a circle. So the more it deviates from a circle, as you can see, the more our foci points spread further away. And, you know, the eccentricity is a factor determining how much it deviates from a circle, okay? So that's what, and so that'll do it for now. We'll get you in another video in a minute.